So thank you all for joining. We will have a talk today about lots of Kotlin code. It has the fancy name Functions Love Testing. Just to quickly introduce ourselves, I'm Christian Dehning. I'm working for Cardigo.
And 1, 2, 1, 2, yes. I'm Dmitry Zaytsev, Dima for short. I don't want to traumatize you by pronouncing my name. And I also work at Cardigo as software engineer. So now after we introduced ourselves, we would also like you guys to introduce yourselves. And in particular, I would like to ask you, who of you is Android developer? Amazing, yes. And the next question, who already had a chance to work with Kotlin? Even better. It makes things much, much simpler. And the last question, who worked with RX Java? Wow, this is just perfect audience.
Very
awesome.
good.
Now, give me the thing. Thanks. So, yes, let's make testing fun. Huh. Amazing. To illustrate the point, we decided to come up with a test task to work with. And since we are a car-sharing company and daughter of Daimler, obviously the test task would be, well, I guess you can guess it, the chat client. So any chat client, you know, probably has two types of messages. The messages from the server and the messages which you are sending to the server, which are perhaps not sent yet, so they're cached locally in a way and waiting in the queue.
Okay, and we thought, okay, testing is not always as straightforward in Android as we would like it to have. So it always starts up with code that you figure out is untestable, and you need to put in a lot of effort to make it testable somehow. So what we thought of was, for this presentation, we will start with really ugly code that is definitely not testable, and we go through why it is not, and then we will go through how we can split it up and how we can make it testable somehow and how we can make tests super fun at the end. So that's the plan. Okay, but that means we now need to look at some ugly untestable code first. And I hope you like code because we will look at a lot of it today. So good that you all know Kotlin and Reactive and that kind of stuff. So let's go. So we came up with this code for our test message. I hope it's readable. Throughout the talk, it will get better because the functions will get smaller and smaller. Basically, if you want to have a chat client, then you kind of need to have a login because you need to be authenticated. So Android code of checking if you're logged in or not would be using an account manager of some style and loading accounts, checking if you're logged in or not. And what we did for the ugly code, we basically jammed everything that we needed for this chat into one activity, so it will look really awesome. Then you want to check if your user is logged in. If not, she probably shouldn't see any messages at all. But if he's logged in, then the logical part starts. We need to figure out first what is the channel the user is currently looking at. Then display some kind of loading indicator because we didn't load any messages at all yet. And then, because we're in Android and we shouldn't do everything on the UI thread, we need to go somehow into the background, execute some executor, and then load both server and local messages. And then we combine those lists together, sort them somehow, filter out stuff that is duplicated, all that kind of fun stuff. And then we can finally go back to running on the UI thread, updating our UI, stopping the loading indicator, and then we finally see something. So I hope everyone is now screaming internally, because this is not how your code should look like anymore, and it's definitely not testable. And now we want to go through the fun part of the presentation. So what makes this stuff untestable? So there's two major things in this code. There's a lot of native Android classes involved here. And if you want to write a unit test, and we're only talking about unit tests today because we want tests that execute in milliseconds, we roughly have 2,000 unit tests in our Cardigo application at the moment, and they run through in like 20, 30 seconds or so. It's only achievable with unit tests. So Android classes are kind of in your way because they will not do anything. They will just throw exceptions at you and tell them, hey, you need to mock me. there is no implementation when you run them inside unit tests. So you need to somehow get rid of them or mock them. We prefer to get rid of them as much as possible because mocking the account manager is no fun at all. And then also we said this whole class is an activity, which makes it also an Android class. So the whole class and its constructor will go crazy if you try to set them up, inject some dependencies. They will just not work. And then finally, we switched threads twice in this simple example. We went into a background thread and then we came back to a UI thread. And switching threads in unit tests is slowing stuff down because you need to start waiting for events to happen. You need to, worst case, add some sleep statement somewhere. So basically it makes your unit tests harder to write because you need to keep aware of that it's not just one thread. And then we came up with what can we do about this. So the simple idea that we will throughout the talk go over and over again is we cut stuff into pieces a lot, as much as possible, to divide the things that are untestable from the things that contain the core logic of the code and you want actually to write the test for. So you don't want to check if the account manager is doing its work correctly, hopefully it does on every device everywhere. You want to check if the business logic of your code is working. So we split it up a bit and we came up with a lot. So we'll go through it one by one because that's how we would have done it if that was code inside our application. So at the very bottom, we at some point need some kind of activity or fragment, something that displays something to the user. Should be as slim as possible, contain almost nothing because it has Android code inside, so it's not going to be testable. So everything that's not about updating a view with something should not be in there anymore. So it's really, really tiny. And then we tend to use MVP a lot to have a presenter that helps moving stuff out of the activities, which will also be pretty slim because it's only thing it does is making sure that the state the activity needs to show is built up correctly, and that's it. So it has subscription, subscribes to some data, and then makes sure that the viewer shows it, and that's basically it. So from somewhere all this data needs to come that is shown in the activity. So we have many small classes that do isolated parts of the code. And we came up with having providers. We didn't want to call stuff managers anymore, but it's basically small classes. We will have a look at one of them later. And basically you need two kinds of messages being provided. There's messages that are only local, messages that were only from the server. And then if you want to load something from a server, then probably you need to have some HTTP client generated somewhere. And then we would also have a provider that tells you about which channel is used because it needs to be extracted in an isolated part because both server and local messages kind of need to know which channel is the current one and want to do something with it. And then on the other side, we also said there will be some login state handling. So something needs to read out the stuff from the account manager and check is the user logged in or not. And the login state provider is the one that will then just basically make one Boolean flag observable for you, which will be the user's logged in, the user's not logged in. And then finally, we have one more provider which will just combine everything together. So this is the one where the actual logic moved into. It will react to the user being logged in or not, and it will merge server and local messages together and prepare just the right object that the presenter needs to show to the view. So that basically every logic moved away from the Android code. If we still had Android code that we kind of rely on, we moved it also somewhere else, but it's split apart into tiny, tiny pieces. And the good thing about this is that most of those pieces are now testable because we don't have anything in there anymore that can go wrong. And then we had a look and wanted to basically show them all to you, but someone said we only have 45 minutes in this talk. So we said, okay, let's strip away stuff. So we started with, okay, there are those classes that rely on Android code. We would write tests with very high effort for them, but you wouldn't see much from it, so we just stripped them away. And also generated HTTP client testing is kind of awkward, so let's not do this. And then we checked, okay, most of those providers at the top will look more or less the same. They just, some of them have more code, some of them have less. So we said, okay, let's just show one of them, the most interesting one, which has most of the logic for our sample application, which is the combined provider. So it's good, we're down to 2. And then we kind of timed this and we're checking, it's still too much stuff. So sadly, we had to look again at what we really want to test in our code. And the most important parts for us were business logic-wise. If the user is logged in, if he's not logged in, he shouldn't see any messages. If he's logged in, then the messages need to be merged together and sorted and worked on. And this is like the core logic part of this application. So we said, luckily this is all in the combined provider, so we'll just look into this one. And now we will go through this provider, show you step by step how it looks like, how we merge stuff out of there, and then how we were able to write tests for them, and then improving slide by slide, making it better. So let's look at it together, finally some more code. So this is the code for the provider, what we ended up with. And basically we said we will need to merge 3 kinds of data streams in there. We need to look at the login status, we need to look at server messages and local messages. So imagine we have some dependency injection set up here, and we will just use those 3 things as our sources of data in here. And then the class itself has only one public member, which is an observable list of messages. So that's what we wanted to end up with in the presenter. The presenter just wants the messages to show for the activity. And now the fun part, how we got there. So the first thing we did is, first we need to check, hey, is the user logged in? Should we load any messages at all or not? And then basically we observe on the login provider, hey, what is the login status? Is he logged in or not? So we can also react to someone logging out. And then we have a switch map on it, just to check, is the user not logged in? Then just show him an empty list once, and then we're done. We don't need to load anything. But if the user is logged in, then we start observing the messages. So basically everything that's not login related is moved into this observe messages method. And this one uses the 2 observables of local messages and server messages, combines always the latest state of them together. And then the interesting part of merging the 2 lists together is the function that we provide for combine latest, which is then basically doing what we had in the ugly code before. It's merging the 2 lists together, filtering, thank you for turning off the light, and then sorting the list, doing whatever crazy stuff we can come up with. But this is where the logic went. And now to the point of the presentation is about, this is now finally testable code, because there's no thread switching involved at all. It will not be in your way anymore, and there's also no reference to any Android class at all. So let's check how we can test this.
I was allowed to talk, finally. So, time to test it, right. We are using Mockito in Car2Go. Who worked with Mockito? Okay, pretty much the same picture. So, in short, for people who don't know, it allows you to replace a real implementation of the class with what you want. Let's say, we can say that login state provider will always return true, or will always return false, like whatever you want, so that you can test your behaviors, really. Okay, what do? We set up the basic test. We say that it runs with a Mockito JUnit runner, which allows us to use those fancy mock annotations and inject mocks, which means that those classes are now ready to be mocked. Then inject mocks means that our tested class, the class which we are testing, will use mocks instead of the real objects. And finally, we have the subscriber for RxJava just to test the output of the classes. If you don't use RxJava, this would be, well, you will not have it. Instead, you will have assert that one value equals to another, which is pretty much the same, just a different world. Then finally, our first test, which is pretty simple. No messages should be shown for logged out user. What do we have? We have a given statement that login status provider will always return false, and we don't care what the other 2 are doing because they shouldn't even be called. And then when we subscribe to our combined messages provider, we should get an empty list. Well, that's straightforward. Then to the next test, which is a bit more interesting. Load messages for logged in users, sort by date, remove duplicates, and filter out deleted ones. Yes, that's what we want to test. What do we have? We have a bunch of messages, A, B, and C. One of them is marked as deleted, which means that, well, maybe you, in your application, wanted to delete it, and you don't want to show it anymore. Then we have the Mockito setup. Again, we have given that login status provider will always return true, and then given that local messages provider will return a list of messages A and C, then server messages provider will return list of messages B, A, and C. You can scramble them in any order, but we're testing the sorting as well. And then finally, we call our class and assert that result is equal to A and B, which it should be because we sort them and then we remove the deleted ones. And also remove the duplicates, right? Wow, we just went in like 15 minutes from untestable code to our first test. And I mean, isn't this cool? No, it isn't, because there's so much setup needed just to test this tiny piece of logic, which we actually want to test. And then, okay, this is one class, but we also excluded the presenter. We also excluded some other providers. And I mean, this is not even a real app. In the real app, you'll have much, much, much more of those. Frankly speaking, it's just boring. Sometimes, I'm TDD guy, and even I sometimes question myself, do I have to do this? Well, maybe we can split up some more things to simplify this. So one thing we're actually interested in is that we have login status. Are we logged in or are we not logged in? And we have some messages. We don't care which messages, actually. They're just messages. And then at the end, as a result, we want to get, again, messages, but maybe empty list or not empty list. So, okay, let's write the code which actually does this. That's it, really. And I mean, this is the same font size we used throughout the presentation so far, so I will be a kind guy and make it bigger. Yeah, let's look at it in more details. What do we have here? We have a function called messages only if logged in. Awesome name, you can come up with a better one, let me know. And two parameters. First one is logged in, which is observable to Boolean. I'll just say Boolean because, well, to make it shorter. And the messages, list of messages. And it returns us the observable to the list of messages. And what it does, well, as Chris explained before, it checks if we are logged in, then we return messages. If we are logged out, then we return list of empty messages. Well, simple as that, nothing else. Can we test it? Well, sure we can. That's how we do it. This is the test which is needed for this function. Again, we set up the messages which we need, just dummy data, you can put whatever you want. And we call the function with the parameters. That's it, nothing else. As you can notice, there is no Mockito involved at all at any point. There are no even classes involved, so no whatever provider. Just call function with true and with some list. Simple as that. As a result, we test that messages are indeed equals to the messages which we want, because user was logged in and we have the list of messages. We might go on and write another test for logged out case, but I'm sure you can figure out how it will look like, just with a false value here, again with the messages, but here we'll assert that this is an empty list. This is pretty easy to write, both the code and the test. The second interesting part is that we have messages from the server, we have local messages, and we want to somehow combine them. Again, we write a function, combine messages, which takes two lists and does exactly the same logic. Well, I'll be fair, I just copied and pasted it from the class before. And it does some magic for filtering out stuff, making it distinct, sorts it by whatever. I mean, it depends on your application, obviously. How do we test it? Exactly in the same way. We create the dummy messages as before. I copy and pasted it because that's what I do every day. And we just call it with two lists, surprise. And at the end, we assert that result is equal to another list. Yeah, I mean, it's so dumb that I'm even a bit ashamed to explain it, but okay, now what? We have those two functions, but I mean, they are not used yet anywhere in the code. First of all, where do we get this logged in state from? Where do we get the messages from? How do we use it? Pretty simple. We take our combined messages provider, remove everything from there, and just use our functions. So we have messages only if logged in. We pass as a logged in state as a parameter from the provider. And as a messages, we pass a result of combined messages function. So yeah, we now use two tested functions in our code, which is great. How do we test the combined messages provider now? Well, this is a bit tricky part, isn't it? Because you cannot mock functions in Kotlin, and well, using power mock is also not really pretty. So what is the solution? Solution turns out to be pretty simple. We don't. And you might ask, what? But then, if you'll think about it, what do we actually test there? Okay, we can pretend that we'll test this code by extracting yet another class, call it messages combiner, which does this, messages combination stuff from before, and then use it as a dependency of combined messages provider, and then have this code tested with Mockito. But now, let's pause for a second. We don't really test anything here. We test exactly the same function as before, because when you say that you mock messages, it doesn't mean that you tested it. Well, we passed the correct value where we need. So, all in all, the class with the functions is now serving more as a dependency provider for the functions themselves. So we don't test the class anymore, because you don't test the Dagger, for instance, that you put the correct instances in your components or your modules, or any other dependency injection framework, except for RoboJuice, because it's dead. So, yeah, by using functions, you write less code and you test exactly the same amount of code, so the same coverage. Well, the coverage would be displayed as less, because technically this code is not covered by the test, but we know that we tested that. Okay, a bit more complicated example. Sometimes we have classes which don't provide the data, but instead doing something. How do we test those with functions? Easy in Kotlin. Let's say we have function fetch messages, which is supposed to get messages from somewhere, again, I don't care where, and save them somehow, I don't care how. We would write a function for that, which takes two parameters, which are a bit special now. They are both other functions. So the fetch parameter is a function which takes nothing and returns a list of messages. And the save parameter is another function which takes a list and returns nothing, and hopefully saves it. But again, it's out of scope of this function. What do? We just call fetch, get our messages, and call save, and put our messages in. I mean, these are really two lines, and it might sound or look, I mean, for me at the beginning it looked like we don't even need this function because it's so stupid, but actually if you write it with classes, it would look more, professional perhaps, but it doesn't mean that it does much more. So in the end, we really just need those two lines. Now, how do we test this? Again, create a class, fetch messages and save them. One interesting thing which I added is that we have a variable now, saved messages, which is initially a null, which is a list of messages. And then we call fetch messages function, but as a parameters we pass two lambdas. For the fetch, we pass a lambda which always returns a list of messages, so it pretends that we are fetching messages even though it's a local variable. And the second lambda is saving messages into a local variable, so we pretend that we save them. And by the end of the call, we expect that messages were indeed saved and updated to our messages from the given statement. So this replaces verify from Mockito for us. We don't call verify that some messages saver was called with those parameters, so this is also a bit shorter. Okay, selling points, all in all. Testing with functions allows you to write less code, but test exactly the same amount of logic, which is nice. Second interesting part, which I forgot to mention, when you're using Mockito, it doesn't play so well with Kotlin because mocking final classes and functions is, yeah, not really. I don't know, maybe in the latest Mockito versions it is supported, but we are still stuck with a bit old one.
Yeah, they basically went now the PowerMock way of rewriting whole classes just to make stuff like this possible.
Okay, fine. Still, at least with the old Mockito versions, you don't need to add opens to your classes anymore. So open begins to mean what it is supposed to mean, that class is really open and not that you use it for the testing somewhere. Then, important point, this is not an architecture, this is not MVP, whatever. This is just an approach to writing code, really. You can start doing it now. You just take next class you write, you try this out. The users of your class will not even notice that you're trying it. Well, unless they open it, but yeah. No. Okay, so just try it. Functions are also more usable. As you might have noticed, I said quite a lot of I don't care during the presentation. That's because functions really don't care where the data comes from. They just care about the type of the data. So you can apply the same function again and again and again for different use cases. For those who don't test their code already, this is actually quite an easy start because as you saw before, for unit testing our class, we had to extract quite some classes here and there and use the dependency injection or inversion of control. If you don't have this yet, you can just start extracting functions and test those and use those functions in your untested code. So it would be already something. Last but not least, yes, we were talking about unit tests so far, but actually with functions it would be easier to write integration tests because with classes usually when you do integration tests it's like you cover either everything or nothing. It's hard to put the boundaries of how much you want to include in your integration tests. With functions you add functions as a parameters to other functions, to other functions, to other functions, up until the point where you're comfortable with this, and then you test this portion. So, anticipating maybe some frequently asked questions, which I thought I would be asked, but no one asked me. Some might ask, hey, aren't we just testing private functions here, like private methods, sorry? I mean, we just took the logic from the private method and made it public and kind of tested it. Isn't this a bad practice? Yes, it is a bad practice to test private methods, but there is a difference between a method and a function, and it is that your function doesn't have an access to your class, and it is really reusable. Function takes all the dependencies as a parameters at the input, unlike with a private method, which can operate with any craziness which class has. So it is different. Can I do it in PHP? Maybe. Can I do it in Java? Yes, you can do it in Java as well. It would be just not as nice as, well, with everything in Kotlin. In fact, you can do it with JavaScript, you can do it with C, C++, whatever, with any language. So just extract the logic into a function and test it. Yeah, simple as that. How do I start? using functions. As I said, you just pick some private method perhaps, or public method from your class, move it outside, replace all dependencies of this method with parameters. So instead of referring to the class, it refers to arguments of the function. And well, you are ready to use it. For instance, if we'll go a bit lazy way and take our dirty code from before, we have this all messages combination logic here. We can actually simply replace it with combined messages, which is tested now. So it is, you know, a glimpse of light in this darkness. And you have at least some tests. So this might be too much, but we have 15 minutes anyway, which is nice. And we are open for for questions now and also today afterwards at our Car2Go stand, which I already forgot where it is, but I'm sure someone will show me.
It's just downstairs.
Yes, okay, so you'll find us there and we'll be happy to answer your questions. Also, maybe you can write to us. Gives are awesome.
Yeah, that was basically our talk. Feel free to check, and by the way, we're hiring, but feel free to ask any questions if you have some now.
Thanks a lot for the talk. I'm curious to know how you organize these functions that you extract. Do you put them in the same file where you have the main class, or you move them to a different file, for example, or, well, yeah.
Right now, we're mostly putting them into the same file where class is. If we feel that function is reusable, then we move it outside into a file of its own. Yeah, but really it's up to you. So.
Couple of questions, one related to the structure. So all functions are public, as I understand, and basically they are visible for entire application, and for example, your auto completion is populated with all your functions.
Well, it's not really populated because, well, we also have lots of classes. So when you start typing, something always pops up. It's fine. But yeah, they're all public. Well, to be more precise, they're all internal, which is kind of like public. But if you use it, if you write libraries, then they are not visible to users of your library. But yeah, all in all, in short, they're all public.
Yes.
So question is, if we replace defer with just which test will catch this? Well, no test will catch this, but we also don't have the test for that with classes as well. This is because we consider this to be, you know, as a setup more, and we don't test this because in practice, it never helped us really.
So you could write a test for this just to make sure that the defer is doing what you want. Usually our providers in our code also heavily use share or replay and ref count together just to make sure that the providers are reusable. But basically you only want to check if that code works once and test it in like one place, because it's going to be used in every of those providers. So our super small example already ended up in like 5 or 6 providers that would all have kind of the same setup. They would all have defer. Some of them would be reusable, so they would share as well what they emit. But you don't want to write those tests over and over again, which you would do if all your code that you really need to test is not inside, it's not outside in the functions, so you can test just the functions. But you would, for every of those providers, write certain tests, and we did this a lot, that were all about checking if we really use the reply one ref count or the defer. So it's a trade-off of what you need to repeat in testing as well, because the more effort it is to write just the one test you want to get to the point where you really test that function. If that's too high, it's really not fun anymore to write tests. So we try to slim it down as much as possible.
Okay, and the last question, partially related to your talk, why you are stick to old version of Mockito? Thanks.
Yeah, we tried PowerMock. It's awesome. We tried to get rid of it again. So what it's more about is getting to use Mockito now less. We had some trouble when we went from hundreds of tests to thousands of tests with running tests. So just using PowerMock on a test class means that PowerMock will start rewriting classes for you, which is pretty fast if you have just some tests, but it gets slow when you have a lot. So our unit tests at some point run in like 5 minutes, I think, 2 minutes, maybe, I don't know. No, it was way more. I had like 1 week I came from vacation and then it was just, I couldn't stand it. So PowerMock just has some overhead it adds to every test, and Mockito as well, because it also needs to do some stuff. And your unit tests are really, really fast. And if you want to run 2,000 tests in like 30 seconds, you really need to get rid of those libraries that rewrite classes, because it just takes milliseconds. So.
Also, the problem which PowerMock was helping us to solve before, it was because we were mocking actually the static methods. Instead of, with Kotlin, you can, instead of using the static method, you can pass it as a dependency, also the function as a dependency to another function. So you don't need to mock it anymore. So all in all, short story, we cannot update to the new Mockito because we're still getting rid of PowerMock, and PowerMock doesn't work with new Mockito.
Actually, I have a question about how it works with coroutine.
We don't work with coroutines yet because we still have to find out the use case for them. When everything is reactive, it kind of...
No, actually, I'm not a fan of ReactiveX. So I've only question is about...
I'm not a fan of coroutines. Yeah, well.
So I have just a question about compatibility with how the test use compatibility with coroutine. That, you know, the coroutine might be in the future the core of the library of Kotlin language. Yeah. So, well, how about the roadmap? So will be a plugin or something support with coroutine? So
well, with coroutines, it would be, as I imagine, it would be actually the same as with any multi-threading things. For instance, if you have, you might use executor instead of async methods, for instance. This would be not as fancy. It's, well, mean kind of different thing, but still you move execution to some other thread. And you don't test this in unit tests. So what I imagine you will have to do, you'll have to test your function, which doesn't use coroutines, and then use this function in the code which uses coroutines.
So that means I can use Mockito, for example, directly with the codes based on coroutine or similar libraries, except ReactiveX.
Can't tell for sure for now, but I think you will be able to. I think,
okay.
I don't know.
I try. Thank you.
So, preface this by saying I'm a Golang dev. So, in using these patterns and starting to move away from using object-oriented type modalities, are you guys seeing advantages in using more functional languages?
So I think yes. Now for the functional guys, I know this looks like a kindergarten probably, but I think it's an easy introduction to a functional world, and we'll see how we will use more and more practices from functional programming. Yeah. Because
and I think we all came from OOP, the functional guys, as it were. So I mean, we understand the challenges that come from these paradigms, but you know, in moving beyond them, obviously functional languages have their own challenges, but you know, we're getting rid of some of these dependencies that or falsivities that came with the OOP paradigm.
So we see the benefits of functional programming for now. But again, as I said, we are not going too crazy with replacing our OP thing with just functions. So we use functions and classes, so kind of a hybrid approach. Any more questions? Then thank you very much, and you can find us downstairs.